Okay, still on the gas laws, we have looked at Boyle's law and we have solved some questions on Boyle's law and Charles' law. But this time I want to look at a general gas law or general gas equation. The general gas equation combines both Boyle's law and Charles' law. That is PV over T. Now, Boyle's law is what? P1 V1 equals to what? P2 V2. While Charles' law is what? P1 over T1 equals to P2 over T2. But this time around, if you combine the two laws, you have PV over T. Now, if you put them into when you have two equations, we have two or more gases, then you have P1 V1 over T1 equals what? P2 V2 over T2. Now, the only thing here is that normally you cannot have all the variables, all the parameters. One is going to be missing. Now we have six parameters here. Now, what are the parameters? We have P1 V1 T1 P2 V2 T2. Most especially, you can be fine to find. You will be given all the parameters. Then you can be asked to find the volume, the pressure, the volume, first volume, second volume. So the parameters: P1 is the initial pressure, V1 is initial volume, T1 is initial temperature in Kelvin, P2 final pressure, then V2 final volume, then T2 final temperature in Kelvin. Most importantly, you have to take note that temperature will always be given in degrees Celsius, but you have to convert it back to Kelvin. You solve only with Kelvin because but if the temperature is given to you in degrees Celsius, just to make sure that you know what you're doing, then you quickly add plus 273 to convert it back to Kelvin. When pressure, volume, and temperature all changes, like this one is very common for waec and JAMB. Most importantly, if you don't want to fail anything when it comes to general gas equation, then you must change your temperature from degrees Celsius to Kelvin, and don't ever make the mistake. And there's something I also want to let you know, that most of the time the question comes at STP. Now, if you go back to the parameters, if at STP 500 volume of something was given to you, and then at STP means what? A standard temperature and pressure. The standard temperature there is what? 0 degree. And if I convert 0 degrees Celsius to Kelvin, that's 0 plus 273, that's 273 Kelvin. That is the standard temperature. And the standard pressure is what? 760 mmHg or 1 atm. So if you are given a question at STP, then two variables, two quantities, two parameters have been given to you straight. That is the temperature and the pressure. So the first pressure there is 760 mmHg. Then the first temperature there is what? That is 273 K. Then you can begin to read along and pick out the important ones there. So that is in case of at STP. That's common to JAMB general gas equation. So at STP is something to distract, but still very, very, in fact, still the easiest and simplest, because at STP, the volume of something was given to you. So at STP you have what? 0 degrees straight, which is 273 Kelvin, and pressure, which is 760. So, and don't forget that your temperature must always be in Kelvin if you want to solve. Now let's look at the first example. They said a gas occupies 200 cm3 at 760 mmHg and 27 degrees Celsius. Find the volume at 380 mmHg and 127. Now, I told you 6 parameters you are required, but one will be missing. So if you have to look at this, the first thing here is what? 200 cm3, that's volume 1. Then that's pressure 1, that's 760. That's of P1. This one is your V1. Then this one is your P1. And this one is your T1. Then find the volume. So this one is your V2, which you are looking for. This is unknown. Then P2, that's the P2 is at 360 mmHg, and your T2 is 127. The first thing we are going to do here is quickly convert the temperature from degrees Celsius to Kelvin. Then how do you do that? Just add 27 plus 273, that's 300 K for T1. Then for T2, that's T2 equals to what? 127 plus 273, that's 400 K in Kelvin. Then what's our volume 1? 200 cm3. Volume 2 unknown. P1 760, then P2 380. So I think with that we have gotten what we wanted. So P1 V1, look at P1 V1 over T1 equals what? P2 V2 over T2. You can see your see your P1 here, then see your V1 here, then see your T1 here. Then this is your what? P2, this is your V2 over what? T2. So if you do all your calculations together, you cross multiply, then you put these ones together. So we have 200 times 760 times 400 equals to 300 times 380 V2. Then times all these ones together, you have 608000 divided by, you count on, that's 114000. Make V2 the total formula, then you have 533.3 cm3. That is your answer using the formula P1 V1 over T1 equals to P2 V2 over T2. You can see that's a very, very simple question. So it's not that hard. So let's move on to the next. There's another question here. We are looking for pressure. A gas has a volume of 400 cm3. That's volume 1. At 27 degrees, that's temperature 1. 760, that's P1. So V1 400 cm3, P1 760, then T1 27, then you convert to Kelvin. And that's not the end of the question. So what pressure will he have at? That's, we are looking for P2. Then your T2 has been given to 127 plus 273, and you have your V2. You can see this one is 800 cm3. So you can see this is what? Your V1 400, your V2 800, P1 760, then P2 is unknown. Then our T1 27, then convert it to Kelvin. T2 is 127, convert it to Kelvin. So you can see that using the formula P1 V1 over T1 equals what? P2 V2 over T2. Cross multiply, put all these together, put all of them together. So you have 760 times 400 times 400. Then take 800 to the other side. That's 800 times 300 P2. Then make P2 the formula. Then the answer is what? 406.7 mmHg. That's the second pressure. Don't forget the formula P1 V1 over T1 equals what? P2 V2 over T2. So don't make any mistake. Common mistakes, common exam mistakes include, using degrees Celsius instead of converting to Kelvin. If you fail to convert to Kelvin, then you miss it. You won't get the right answer. Then forgetting to cross multiply. You can see we have cross multiply. The mixing pressure unit. If you are given an ATM, we have to convert to 760 unless you want to solve everything. So that is a quick summary of the everything. So the formula, don't forget temperature in Kelvin, and this what you are saying and now is what? The general gas equation or the general gas law that combine Boyle's law and Charles' law together. Look at the front of some of the examples we are giving. They are very simple. 6 constants, 6 parameters will be given to you, but one will be missing. So P1 can be given, V1 can be given, T1 can be given, P2 you look for if you are giving the other. So it's just like normal simple mathematics, and so that is it. And don't forget at STP. If at STP was given, that means what? The standard temperature was given to you, that's 0 degree, and standard pressure was 760 mmHg or 1 atm or 1 atmospheric pressure. So that is the end of that. See you in our next video. Thank you.